Hello everyone, I'm Trishul. I'm a front-end developer and a JavaScript enthusiast. By the day, I architect some JavaScript solutions for Westwing, and by night, I'm a Mozilla volunteer. Today, I'll be talking about destructuring front-end monoliths with microfrontends. What are monoliths? Monoliths are self-contained applications. The components of these applications are tightly coupled and interdependent on each other. Monolithic application is designed to be self-contained. Components of program are interconnected and interdependent. It is typically all-in-one solution having all modules from database connections to UI elements. In modern day, this huge monolith is already broken into front-end and back-end. Furthermore, the back-end is split into various microservices. These worked fine, but with the evolution of JavaScript, the front-end now has way more code than before. Front-end houses a major chunk of business logic. Eventually, front-end now has huge amount of code and also its complexities. Over the time, it grows, and now what we have is called something front-end monolith. And with this, we again have the problems of monoliths. All code in a single place. With each feature, the code size increases, the code complexity increases, the maintenance cost increases. And as teams are working on the same code, the interdependencies of the team increases, the friction increases. Eventually, result of these, the development to deploy cycle slows down. Moreover, on top of this, the whole system is as strong as the weakest link. If one team breaks anything, the other team are blocked too. No deployment can be done until the breakage is fixed. So, what's our solution? Enters Microfrontend. What is Microfrontend? Microfrontend architecture is a design pattern where a monolithic frontend app is restructured into small independent apps. These micro apps are stitched together as a single page on the fly. Each of these apps is a microfrontend, and each microfrontend is a standalone system capable of running on its own. Each of them has an individual repository. There is no direct code dependencies between these two apps. Each app is built individually and ran individually. Since repositories are independent, they can have independent pipelines. They can run their own test suites, their own build process, etc. And most importantly, each one has independent deployment system. One microfrontend do not have to depend on other microfrontend to be able to deploy. Even if one microfrontend is blocked due to, let's say, some errors or some bugs, the other microfrontends are free to deploy without impacting the broken one. So on a whole, this whole system enables parallel development cycles for different teams, independent and individual of each other. So now let's have a look how this whole thing is architected. There are several microfrontends, let's call them remotes. They expose their modules in the wild. Then there is a host which consumes these exposed modules as and when required to build the complete page. Now, the host does not need to care about these modules, where they were built, where they were compiled, or how they were exposed. The only thing it knows is a remote address where it can refer to and download the modules. Let's have a look in more realistic word. So let's consider this an e-commerce website. It has a header, footer, and few pages like home page, listing page, details page, payments cart, etc. In a monolithic app, all these would be in a single code base. But with microfrontends, you can make each page as a separate microfrontend, independent of each other, and each team is responsible for this microfrontend can move with their own velocity. And this all microfrontends will be hosted in a host, or let's say app shell, which will contain header and footer. So when, let's say, someone requests for a home page, the app shell will load the homepage microfrontend and serve the complete page as a home page. What should app shell have? App shell has header, footer, and it should have some shared business logic. All the shared business logic should be put in app shell so that it is available for sharing throughout microfrontends. So what kind of modules we can put in shared business logic? Let's say login. The microfrontends should depend on app shell to get login data, as well as trigger login pop-ups or mechanism in case they want the user to log in. Next thing they can put is shared tracking. The tracking adapters are implemented in app shell. Microfrontends pass messages to app shell when they need to send tracking signals. Then we can put global configs in app shell so that every micro frontend can rely on app shell rather than request it individually. And let's put routing in app shell. App shell is responsible for creating the page. So the whole routing is in app shell so that it knows what micro frontend has to be served on which route. This is just an example how we structured our code in Westwing. This can be different for different use cases. Maybe people want your use case could be the tracking should not be in app shell but individual micro frontend, because let's say one micro frontend does differently and the other one does other way. So next, communication. In the micro frontend architecture, there's a lot of message passing. The micro frontends needs to communicate to each other and as well as to the app shell. Generally, there can be two cases. First, all the micro frontend and app shells are in same tech stack, let's say React. So it can be as easy as passing down the props. You pass down the props and the system reacts. The other thing can be different tech stack. It can be Vue, it can be React, it can be Angular. In that case, you cannot just pass down the props. In that case, we can exploit custom DOM events. These custom DOM events are tech stack agnostic and are native to JS. So pretty simple to use and pretty effective. So let's have a look at a custom DOM event. So all we need to do is just subscribe to a custom event. Let's call it my event. And then when we need to trigger this event, we can just create a custom event with the new custom event constructor, pass the data, and simply dispatch the event. This dispatched event will be intercepted by the listener and the action will be done accordingly. This listener can be in another frontend and this trigger can be in another frontend, and this will work seamlessly across. So now we have an idea how this whole thing is architected. Now let's look a bit more how this is actually implemented. Some traditional approaches. So one of the very traditional approach is node module. So what we do is each of micro frontend or each, let's say, part of the code is a node module, and we kind of import it into the main app. Let's call it app shell or host app. And then when we build it, it downloads the node module, it implements the node module, and it binds the node modules with the main bundle of the host app and serves it. So this is fine, but still it has constraints, lots of constraints. For example, you cannot do independent deployment. And the other one, which I'm not super sure that we should use it, but iframes. Like you can serve the code from different domains or subdomains into iframes into your website. So obviously these are not the best optimal approaches, but with Webpack 5, we have module federation. So what is module federation? Module federation allows Webpack to reference remote modules which are not available or known at the compile time. These modules would be known only at the runtime. So consider this again. All the remotes are compiled separately from the host. Host has no idea how it is being done. All it is caring about, it should be available on a remote address. The host just references these micro frontends during its compile time and does not look for their availability at all. So let's see how to do this in code. Consider a small component. Let's call it main.jsx. So all this component does is renders a title. So this is how you expose remotes. All you need to do is include a module federation plugin in your Webpack config and then define a namespace for your remote, let's say remote 1. And then you have to name a file name for remote entry. So let's call it remoteentry.js. So what this file is pretty significant. This holds all the metadata for your remote. Basically, what all packages are there, how they are connected, which needs to be loaded when, and so on. And then the expose component. This is the component which is exposed, and this is the namespace which your host needs to use while referencing this micro frontend. And then finally, shared. So in shared, we mention all the resources which can be shared from the host. So for example, if host and remote both use React, you do not need to load 2 instances of React. You can just say like share it from the host, and you do not need to load React from the micro frontend. Now, this expose module has to be consumed by host, and this is how you consume in host. So in Webpack config of host, we need to include module federation plugin. Just name the namespace for your host, and then you have to define remotes. Like, okay, this is the remote namespace remote one, and it is available at this address. And again, the shared component. The shared component, like these components are, these resources are available for sharing. Okay. Now, how this whole thing is wired up. So if you see, this is a simple app and it imports the remote component. So this is the remote namespace, remote one, and this is the expose component namespace, main. And then this is used like any other React component. You can pass the props to it, you can do some action on it, and whatever you want to do, you can do with this component as if it was the native component of this app. This looks pretty simple, and believe me, it is exactly this. We don't need to do anything else to make sure our module federation should work. So let's check this out with a small demo. For the demo, I have two projects. One is host, one is remote. Let's check out the remote project. So in the Webpack config, we have module federation plugin, we have a Babel loader, and we have a module federation plugin. So it's a namespace remote one. It has a remote entry. It exposes a shared component with the shared component namespace and some shared modules. Let's check our shared component. It's an src shared component. It's a pretty simple component, just having current count, whatever the counter has been passed to it. And it is just consumed as a normal component here because it's the same project. To check this out on the remote, let's check yarn start. Meanwhile, I will explain what is in the host. In the host, we have a Webpack config with module federation plugin, the host, and the remotes definition. So remote one, and the address which is corresponding to remote one, and where they can get remote entry.js, and again some shared modules. Now here, let's have a look at the host app. In the host app, we reference remote one shared component from the remote and use it as a remote component here. And we pass a state variable counter in this. This state variable will be increasing the count from the host, and on every increase, it should pass the counter to the remote component. So it's pretty simple, and let's check if that works. Okay, our remote is ready. Let's quickly check if our remote works. So remote works like this. It is the remote app, and this is our shared component, current count 1. Let's check the current count 1 in the remote app. Yeah, we passed count 1 and we passed the counter 1. So it's showing 1. And now let's see our host app. Let's turn it on. So this should be ready at 3001. Let's check this out. So the same component is here, how it was here. It is 0 because in the host app, we have initialized this one with 0. Now let's increase, and this value is increase in the host, and the same increase value is passed in here. And like any other React component, it is behaving the same. It has no it does not matter it is coming from a shared component or a remote. It seamlessly is integrated as if it was the native code of this app. And that's the power and magic of module federation. In Westwing, we build our whole Microfrontend architecture with module federation, but not everything was a piece of cake. We had some challenges in our setup. So first and foremost, we need to have design consistency. When we split out into multiple microfrontends, one of the biggest challenges was to make sure that everything looks same. The design throughout the system should be same. So what we did is, for this, we use the design system. We have a UI kit which houses all the UI components. All microfrontends use components from this. For example, button, for example, input boxes, check boxes, select boxes, etc. The next challenge we had was initializing a new microfrontend. We need lots of setup in each microfrontend. We wanted almost same code structure. We need CI pipelines for testing. We need CI pipelines for development. We need Helm charts. We need public we need publish to S3 scripts, we need invalidation scripts, etc. For doing this for every micro frontend, it's really a time-taking process and error-prone. So instead of doing this manually, we implemented a templating solution using a tool called as Temporeto. So these tools allow us to kind of create a template, and whenever we need to create a new micro frontend, we just spin up a new instance of this template and we get everything out of the box. For example, if you look here, this is our template repository and it can hold multiple templates. So for us, we have a micro frontend template, and when we select this, we pass some variables for the namespaces and some description, and finally it spins up a whole new project of a micro frontend which out of the box has Docker file, Helm charts, end-to-end test, all the CI pipelines, etc. So this made our life super easy, because not only this helps us to create a new micro frontend, but also it keeps all the templates in the sync. So for example, if we need a new change in all the micro frontends, we do not need to go to each micro frontend and do a change. Instead, we just make a change to a template, and all micro frontends need to just update their template, and all the changes will be already reflecting on their micro frontends. Sounds good, right? But yeah, these were our major problems. Apart from that, we have some small hiccups. For example, decoupling code from the app shell. Like, it was a huge monolith and it was really not super easy to decouple all the code into small micro frontends. It took a while, some complication, and on the process, we have to move lots of the components to design system, because these components were kind of referenced within the code. We have to move it to the UI system and then import it from there, which actually costs lots of time for us, but it's worth it. We have lots of shared logic between the components. For example, let's say price formatting. For different countries, we can have different price formatting, and we want our website to have a same formatting throughout our pages. To make sure we do not break this one, we created some npm packages. We call it them as formatting helpers. So we put all the logic which is kind of shared between all the micro frontends, like price formatting, product formatting, image formatting, into these small npm packages, and refer them from npm packages rather than re-implementing the logic, so that everything is kept in same space. And finally, the biggest problem we had was building an efficient developer experience. Each microfrontend is a standalone system, but while developing, we need to check out how this looks on actual website. For this, a developer would have to install all the microfrontends on his local and the app shell, and then run it simultaneously to make sure the website looks as we want. And trust me, this is chaotic. So instead, we used a Docker-based solution. We exposed a Docker image with all app shell and micro frontend. This image accepts remote URL for all micro frontends. So all we need to do is just run your local micro frontend and pass this local URL into this Docker image via environment variable and just run it. So the website will run everything else from, let's say, staging or production, whatever your configuration is, and the micro frontend which you are trying is running locally. So this is how we solve this problem for developer experience. We have solved almost all the challenges which we faced while implementing micro frontends in Westwing, but still we have a long way to go. But with the current implementation we are seeing already the benefits of micro frontends. Our team velocity has increased, the developer lives are simplified. And with that, thank you everyone for attending my talk.